Yes, thanks. Good morning. I would have loved to be there, but yeah, unfortunately can't. So I'm going to tell a little bit about the details of the compatibility layer and how we build it. Well, this is something most of you now know probably. So the compatibility layer is basically the operating system layer that contains all the OS packages. I think yesterday someone compared it to like the container operating system. So also in a container, you have these operating system packages. So no kernel, that's still part of the host system. But other than that, almost everything that you usually have in your operating system. So everything from glibc and then other kind of tools, libraries, so build tools, text editors, whatever you find convenient, you can put that in this layer. And we have this layer to basically keep the software independent from the client operating system, so that the software packages work on basically any system, regardless of which distro you're running. We chose Gentoo prefix basically because that's one of the only Linux distros that you can install at a custom location. Yesterday in Bart's talk, he also mentioned, for instance, Nix, which would be an alternative that could do the same thing. But when we started EESSI, we also talked to Bart and some other people at Compute Canada, and they just then switched from Nix to Gentoo prefix for reasons that Bart mentioned yesterday, which is why we also went for Gentoo prefix. It also has lots of nice features. It already supports lots of architectures, for instance. So it's basically a very good fit for EESSI. And again, that allows us to basically put this operating system layer into the CVMFS repository, so under /CVMFS, so that we can easily ship it next to our software packages. Well, you can see an example of a path where we put this layer at the bottom of this slide. So we basically built one per CPU family, so per architecture basically. And one per EESSI version. So every time we make a new EESSI release, EESSI version, we make this new version subdirectory. So for instance, 2021.12. And then under that path, we create this compat layer for one for ARM 64, one for PowerPC 64, and one for x86 64, and maybe in the future some more. You also see this Linux directory subdirectory in here in the path. We did that because we still envision or hope to at some point also build a layer for macOS, which should also be supported by Gentoo prefix. So you can build Gentoo prefix for macOS. So then we have to build separate ones for macOS and for specific CPU types. So for instance, ARM and x86 64. But we don't have that yet. I think Terry has looked at that in the I think a few years ago. Then it's somewhat worked, but there were still lots of issues. So at that point, we decided to drop that first and first focus on Linux compat layers. So which packages do we put inside this compatibility layer? So you can have different views, which was also nicely illustrated by Bart's talk yesterday. So they put quite a lot of stuff in the compatibility layer. We started with kind of approach that the fewer packages we put here, the better it is. That's still, I guess, open for discussion. So there are also good arguments to say, well, let's just put all the editors and all the graphical libraries and whatever in this layer, so that you're always sure that you have these even on very minimal systems. So we don't really have very good criteria for what should be where, but in general, we take these few points that I listed here. So if it's not something that is very performance critical, so we don't need to optimize it for particular CPUs, then we can put that into the compatibility layer. So for instance, build tools and stuff like that, also glibc itself, those won't really affect the performance of an application. On the other hand, if you have some mathematical libraries, then you probably do want to optimize them for particular CPUs, and then they should go to the software layer where we make more distinction between different CPU types. Another one is, do we plan to have multiple versions of this tool or library to be installed? If no, then we can probably put it into the compatibility layer. If we do think that we are going to have multiple versions, for instance, for Python, C, Make, etc., it's easier to put them into the software layer, because then we can have these modules that users can just load and unload whenever needed. There are some things that are needed by Gentoo itself, which we also cannot really get rid of, unfortunately. So for instance, Python, that's something which is also part of the operating system, probably the same on all our clusters nowadays. So you always get this default Python version in your operating system, which maybe would be nice to remove, because at least on our clusters, I often see people getting confused. If you don't load a module, you already get a Python version, and then we also offer Python versions as modules. It's easy to start mixing these versions up and start installing stuff for the operating system Python. But yeah, there's not really a way around it. For some packages, you can maybe remove them after you've installed Gentoo prefix. So yesterday, for instance, CMake was mentioned, that is being installed by Gentoo prefix itself as well during the installation process, but you can probably remove that once it's done. For Python, I don't think that's going to work out. And then there's a bunch of packages that we just want to have or need to have in order to make our software stack available in a user-friendly way. So for instance, archspec, we need that in order to find out which CPU you as a user of the stack have in your system. And also lmod, we need that in order to offer the software stack as modules. So we put these tools into our compatibility layer. Then, because we built this layer for different architectures, so at the moment we have 3 different architectures that we support. We of course also want to make them as equal as possible. So it should not happen that once you switch to another system, let's say from x86, 64 to ARM, that you suddenly get a completely different compatibility layer with different versions or whatever. So we always try to stick to the same set of packages for all the architectures whenever possible. So there are some exceptions, like this OPA PSM2 package, which you need for OmniPath. That's not supported on anything else than x86 64. So it's just not possible to install that for the other layers. It also doesn't really make sense, since there are no systems with that combination of CPU and interconnect. But that's just one tiny difference between the layers that we currently have. There may be a few more packages, but those are not really that relevant then, because again, those systems don't exist anyway, so it's not that important. Then next to the packages that you get by default, so when you run the bootstrap script for Gentoo prefix, we install a bunch of packages that we find useful ourselves. And we put that into a so-called package set. That's something that Gentoo supports. So let me quickly show you how that file looks like. I'll click that link. Yeah, I can. So I hope this share still works. So in here, in our GitHub repository, let me zoom in a little bit. You will find different files for different versions and for different architectures. We basically have a script which generates them now for the most recent version. So we have one YAML file basically that has a certain kind of tags that say this package should not be installed for a specific architecture, or this one should only be installed for a specific one. And then based on that YAML file, we basically generate these 3 files. So let's have a look at the x86 64 one. So this is just a list of packages that we basically add on top of the default Gentoo prefix installation. So you see some editors, some Python stuff, some fonts, which we need for graphical applications. There's archspec, there's reframe as well for the testing. lmod is in there. There's some interconnect libraries, so RDMA core, for instance. And some other stuff. So mostly stuff that we've run into, hey, this one is convenient to have as well, or this one we really need to have, then we can easily add it to the set. Whenever you see this ::easy, that means that it comes from our own repository of packages, which I will show in a minute. Whenever that's missing, it will basically says that it doesn't matter where it comes from. So it can come either from the default Gentoo repository or from the easy one. You can also specify a version. So sometimes we really want to make sure that we get a specific version in case there are multiple versions to be installed. So in this case, we deliberately set this to a specific version of archspec that we want to have. So then how do we build the compatibility layer? We basically now use an Ansible playbook. So I can also show that one. So that's all in the compatibility layer GitHub repository. I'll go to the root folder. So all the stuff is here, except for the set files that I just showed. That is in our Gentoo overlay. That's our package repository, basically. So that's in a different repository on GitHub. But other than that, most of the files that you need for the compatibility layer are in the compatibility layer GitHub repository. And then the Ansible playbooks are in the Ansible/playbooks directory, where the main playbook is the install.yaml. That's just a very minimal file that says just apply the following role and then run it on a certain machine. So that is in Ansible terminology. It's this line that says run this compatibility layer role on a machine that is listed as a Stratum 0. That's still some leftover from how we did things before. Right now, we don't build the compatibility layer on the Stratum 0 anymore. So we should probably rename this, but that's just a tag basically that you put in your host file, which says, I want to apply this role on the machine that's listed with this tag. And then when you run that playbook, it's basically going to apply the role from this subdirectory, which has a bunch of tasks that it's going to run. By default, it's going to run the main task, which will then include all the other ones. I don't know what the slide exactly said, but let me just quickly go scroll through this file. So it's first going to do a bunch of checks, for instance, find out if there's already a prefix installation. In that case, we can skip the most time-consuming part, which is building the Gentoo prefix. That takes several hours. So if it finds that there's already one, it will basically just skip that task. So also this is still left over. If you're building on the Stratum 0, you could even run this inside a CVMFS transaction so that you can directly ingest it afterwards. But for the last couple of versions, this was disabled. So there's a condition here, which is usually set to false. So the first step is building that prefix. Again, that takes several hours. And then after that, we make some customization. So those are basically all the subtasks that you can find in the other files. Which can be very simple ones, like adding our own package repository. Let's see, add overlay thing, to making some tiny customizations in terms of configuration to the prefix installation. We also want to make some symlinks to files on the host, so some libraries that you usually have on your host systems, or configuration files like your etc hosts file. We can symlink those back from the Gentoo prefix installation to the host machine, in order that these configuration files are being used from there and not from Gentoo itself. Also, for instance, for stuff like LDAP, we can do that. Although Bart mentioned yesterday that there's also a new approach to this now. So let me quickly go through some of the other files. So for instance, the installation of prefix, that's quite a long task because it involves quite a few steps. The most important thing here is that we only support building this on a CentOS 8 machine right now. I think we did that because installing Singularity on other kinds of systems was a bit tricky. So for now, we more or less just fixed that to a specific OS. There's no really good reason, so we could probably easily modify this. But since we usually do this on a VM in AWS or Azure, we can easily pick an image for an EL8 based system. So it's not that important anyway. So we just need a few dependencies for building the prefix. So we use Singularity and Git. So why do we also use Singularity? While we are already building on a VM, that's mostly because we first want to isolate ourselves from the host. So we, even though the VM is always already quite minimal in terms of packages, the Singularity image, I think, is even more minimal. And that's somewhat important because we want to really prevent that something is being picked up by Gentoo prefix from the host system. So we want to be careful there that it's a completely separate build. And also we can do some tricks there with binding directories to the right location. That's easy to do with Singularity. So we have basically a controlled environment and an environment that is always the same also for the different architectures. Well, then we just start setting things up, making the directories that we need, etc. We do some checks if there's sufficient disk space on this VM, otherwise it might fail after a couple of hours. Then we're going to take the bootstrap script. So in order to install Gentoo prefix, you need this bootstrap script, and then just run that. We made some small customizations to the Gentoo one. During the last couple of months, I think we've removed most of the customizations because we didn't really need them anymore. So it's now almost the same as the upstream version. Then we configure the Gentoo overlay. This is also an important step. So in order to build Gentoo prefix, it's going to install a lot of packages from the Gentoo repository. And this repository changes every, well, almost every hour because they're updating stuff to newer versions. So Gentoo is always quite quick in introducing the latest versions of packages. So if you're not careful and run this bootstrap script, a few hours later, you suddenly get a whole bunch of newer packages. And we want to make sure that whenever we do this, we always get the same kind of state, also because we have to build it 3 times for different architectures. So basically what we do here, we clone the Gentoo repository, which is stored on Git, and then we basically pick a specific commit from the Git repository that we want to use so that we have some kind of fixed state of all these build recipes. So these are these e-build files, which you may have heard of, which are a bit similar to, for instance, easy config. So it's just a recipe for installing a package. And by doing this, we make sure that we always get the same state of this package repository. Well, the rest of this is not that interesting, I think. So this is still setting up stuff. But at some point, it's just going to run the prefix file, the bootstrap script. And then, well, you have to wait for a couple of hours. I think I'm going to skip most of the other ones. Those are not that interesting. Maybe show one more. That's the test one. So at the end, we want to make sure that everything was done correctly. And for this, we also have a reframe test suite, which is a quite simple one. It's not really going to run stuff. It's just going to do some checks. Is this file there? Is this command working, etc. So that's basically what this task is doing. And it's using a Python file with all the tests from the root of the repository. It should be in test here. So I'm not going to go through this entire thing, but you can do that later on if you're interested. Here's just a whole bunch of tests that basically is going to run a command like equery, which is a Gentoo command, and make sure that equery -- version works correctly and has exit code 0. It's kind of a sanity check in easy build, if you're familiar with that. So this should also complete within a few seconds because it's all quite simple. So making sure that our easy set is there and that all the packages have been installed, etc. So I think I handled most of this. So you basically need 3 VMs if you want to build for 3 different architectures. You can do them simultaneously if you want to, and then it's going to run all those steps. I think I mentioned them all. Yeah, so all the customization, so our own package overlay, then install our package set, do some configuration, fixes, etc. And then when it's done, all the tests have passed. We basically make a tarball of the entire compatibility layer for this architecture and send that to the Stratum 0 and ingest it to the repository. Then one warning, because I've seen some people trying to do this while it's not necessary. So maybe that's not entirely clear from the documentation, but this is something that regular users or even sysadmins never really have to do, unless you, of course, want to build your own prefix and use that for local packages, for instance. But in principle, users never really have to go through this procedure, even though this playbook makes it quite easy to do it. But the entire compatibility layer is included in our CVMFS repository, so it's just there. And whenever you're going to mount it, the init scripts will be able to find it and find all the executables in the CVMFS repository. So you don't have to build your own Gentoo prefix layer. But again, if you're interested in this, of course, go ahead. Then one final thing that we've been struggling with a little bit. So sometimes we have to update an existing compatibility layer. Well, why? Sometimes we need extra packages. So we find out it's really useful to have this additional package. or because there's a security vulnerability, and then we have to update a particular package to a newer version. So we also run security checks and report the outcome to a private Slack channel every day. And that sometimes reports, hey, we have to update this version because there's a security vulnerability. Then what we usually do is we get our build container with a writable overlay. I think Kenneth will also explain this a bit in the software layer behind the scenes talk later on, but that's basically a kind of client container for EESSI, but then also with a tool called Fuse Overlay FS, which allows you to build on top of a read-only CVMFS repository. And then it just writes all the changes to some local directory. That allows you to basically load the prefix and start updating or installing additional packages. So that's very easy to do some interactive testing and see if these package updates work, or installation of new packages. But yeah, that's not automated yet. So at some point, we figure out, okay, in order to solve this security vulnerability, we have to do this command in order to update the package, and that works fine. We've tested that, so let's do it and build a new tarball. So we had to do that a few weeks ago. Kenneth has done that, and he built a script for this, which basically contains all the commands in order to update the vulnerable packages. So that can be found in this script, just the whole procedure for basically doing that. There's some tricks in here again, because we have to stick to a new Git commit now in order to get the updated build recipes for the affected packages. And then we had to do some other weird fixes in order to stick to the Python version that we already had. So sometimes it may want to update Python as well, which is quite an involving operation, because then it's going to rebuild lots of stuff depending on Python. And then at some point it's going to rebuild almost the entire Gentoo prefix installation, which is of course not really what we want, because that can be quite dangerous. So there's some tricks in here to prevent that. But then at some point it's just going to say, okay, update this package. So LXML, that was one of the affected packages, Vim and libarchive, and we have to do one more with glibc, which we haven't done yet. So we basically run that script inside our build container, make sure that that succeeds, and then we basically build an entire new tarball of the complete compatibility layer, because it's very difficult to update an existing compatibility layer in CVMFS, because package updates will not only add files, but also remove or modify files. And it's very tricky to find out which files have to be removed from CVMFS later on, because of the way how we do this. We build it on a different build machine. And then on the Stratum 0, we should have to figure out which files to delete, which ones to add, which ones have been modified, etc. Because that's extremely tricky. The easy way out here is just to remove the entire existing compatibility layer and add the new one, the updated one, to the repository. That's what we currently do. We've also looked into using rsync with the -- delete flag, where you can also basically compare two layers and then apply the changes, but that took quite a long time because there's lots of files in the repository. So just removing and replacing that was something that we found easier and quicker to do. But still, it's quite a lot of manual work, so automating this a bit more would also be nice. Well, recent development, I'll keep this short because there's a dedicated presentation on this later today, I think, is adding RISC-V support to Gentoo prefix. So Atharva has been working on this as a Google Summer of Code project. And this should be working now, so you can do a bootstrap of a Gentoo prefix on RISC-V, so that will give you the basic installation. And then we have to install the additional packages that we need, which should also work now, because Atharva has also been working on keywording these packages. And keywording, that means basically adding support for a specific architecture. So usually these build recipes, these e-build files, have a list of keywords, which basically mean if x86-64 is in the list of keywords, that this has been tested and that it should work. So RISC-V was missing for lots of packages, but he added that for all the ones that we need. So in principle, we can start building this, which we could do now already and add that to the existing version, or we can maybe wait for the next version, depending on when we are going to build a new version. One thing that is still missing, but it should probably be trivial to do, is build a build container for a RISC-V so that we can actually build stuff in that container. So some of the future work that we want to do or plan to do, first of all, we are considering to drop the support for PowerPC because that is not being used as far as we know, and it does usually take us quite a lot of time to build it. So usually most of the issues that we see with building the new layers is on PowerPC, and because of all the effort it takes, it doesn't really seem worth the effort to spend a lot of time on it while nobody's using it. So it might be a good idea to drop it and then instead of building PowerPC, build a RISC-V layer. There's also some requests for more packages to be added to the compatibility layer. For instance, this P7 zip that's needed for the script that Alan and Michael have been working on for adding CUDA support. So that can be included in the next version. There's also an issue, I might even have opened that one myself, for adding HTOP, and maybe a few more, but again, that's maybe open for discussion. Do we want to add lots of, for instance, editors as well? So Bart was really in favor of doing that for Compute Canada, while we at first decided not to, but yeah, maybe we can discuss that. There's some other kind of small fixes that we might want to apply for our next version, also regarding these host symlinks, which Bart mentioned yesterday. So there are some better ways to do that now for some of these symlinks, especially the LDAP-based library symlinks. So we should also look into that. And again, this security update thing, which I already mentioned. We also might want to look into that. So right now we're using with a tool provided by Gentoo, which is based on these GLSAs that Gentoo releases. So these are basically security announcements. But there has been a time in the last year where they didn't announce any for at least several months, and they basically stopped doing that. But now they seem to have restarted this. So the last couple of months we've been getting quite a lot of them again. But we might also want to look into other tools. So this week at the CVMFS workshop, I heard someone mentioning this Triffy thing, which is a tool that can scan container images, but it can also just scan file systems for known security issues. So we might also want to run that as a kind of maybe GitHub action or a cron job somewhere, and let that one report security issues as well. And this build procedure, which I explained, that's still quite a lot of manual work. So we probably want to try to automate that so that maybe a GitHub action again or something else that will just at least start testing these package updates that we need to do, and then maybe already prepare a tarball which contains the new version, so that we only have to review that and then basically approve the deployment of the tarball. And finally, something that we are not really doing yet either. Suppose that we need to update glibc, which is the case right now. That might be a bit dangerous. So it could, in principle, happen that an update of glibc breaks lots of stuff. So whenever we are going to do this, it might also be a very good idea to test the impact of these updates on the software layer. So for instance, by running a reframe test suite again and making sure that all the tools, all the GrowMax and TensorFlow versions, etc., still work fine after doing the updates. Well, this is just the usual end slides. So I don't know if there's still time for discussions. We're a bit late, but there are some things that we maybe talk about now or later on. Or if you have any questions about the installation procedure, then also feel free to ask it now, of course.
Not a question for you, but broader. Is there anyone who still cares about power? Like PowerPC 64-bit. Are there any sites still buying new power systems? Is that still happening, or is that a dead end?
It's very silent here. I don't know if
we're just so blown away.
Oh,
The only thing I would point out is that we need a full-scale testing environment to make sure that when we update something like glibc, that the tests are to run retroactively and then figuring out something has broken.
Yeah, no, true. I think Casper also has a talk on testing, I think tomorrow. But yeah, we need that reframe test suite anyway, also to make sure that installations, even without these updates, work fine. But once we have it, we can run it at various scales and at various different times, so we can do a minimal kind of test every, let's say, day, and a more full-blown performance test suite every week or so. But once that's there, then also after a update, we can easily run that again.
And the question I was asking here in the room, but the mic was muted, is if anyone still cares about power, they should speak up. So if we're not hearing anything from anyone, and up until now we haven't, we'll just stop spending time on that in the next version. Yeah. Because we're indeed, like you mentioned, losing quite a bit of time on that, even if it's only waiting until the all the builds that we're running in via QEMU are passing. And I mean, it works in the end, but it's just very slow. So if we don't have to do that again, and we can indeed focus some of those efforts looking forward to RISC-V, that seems more promising.
Yeah, and I guess also from the Gen 2 point of view, they don't really seem to test this on power, because I remember issues where just a glibc update, for instance, suddenly broke things on power.
Yeah, I don't remember if that was the reason that we stuck to a slightly older glibc just because of power, or at least it was related. Maybe it was a broader issue, I'm not sure. But we've certainly had that in the past. And yeah, if power is blocking us and nobody's using it, it doesn't make any sense.
Yeah.
And if the need pops up again, we can revisit that again, or whoever's interested can actively help out with making sure that's that's working. But for now, I guess we should just drop it. Yeah.
Hi, Bob. Apologies for being a little late. I missed most of your presentation. Unfortunately, I'll catch up later. No problem. Regarding the additional packages in the compatibility layer, is there a philosophy behind what to add? Because it feels like that's kind of in danger of scope creep.
Yeah, so I had this slide. I guess you missed that one then. But
sorry about
that. So there's no completely clear philosophy. So there are some general rules, also similar to what Bart mentioned yesterday. So for instance, MPI stuff, I didn't mention that here, but of course MPI stuff should also always go to the software layer. But yeah, it's mostly, is it performance critical, and do we need multiple versions? And based on that, we usually choose if it has to go into the compatibility layer or the software layer.
I guess another aspect there should be, how likely are we going to shoot ourselves in the foot if we add stuff there that's maybe security vulnerable? So if we add more stuff there that's likely that will need to be updated because of security issues, then maybe that's a reason to not do that there.
And maybe how, let's say, confusing it may be for users. So you know, or sysadmins. I mean, if we add lots of stuff to our compatibility layer, which will be added to your path at some point, once you're going to source the init scripts, you suddenly get all the versions that we provide. So that may mix up stuff with even text editors, for instance, which you're used to, that you suddenly get a different version once you're working with EESSI.
And that's actually another aspect, because I don't think if you currently source our init script, you're not getting the tools from our compat layer at all. You're only getting the modules, and if you load the modules, you get software in. But I'm not sure you actually get them from our compat layer unless you do a start prefix thing yourself. And that,
I thought we had added that.
You source it, then the tool, So you do. Okay, then you do get the stuff from the compat layer. That used to be different, I think.
Yeah, I think we had to change it at some point. I forgot the reason, but I don't know if I can easily find it now. But
no, for Elmot, it's not relevant. Elmot has his own init script, and it can find itself. So it doesn't need to be in path at all. Yeah.
So I was actually wondering, in this same point of view, about the very end user, how much is used or needed from the compatibility layer. So for instance, we have Python and Git, which is basically, I guess we have those to bootstrap EasyBuild and build stuff with EasyBuild. But those are not needed by the end user, who just loads modules and uses software. So how do you know how much is actually needed? from the compatibility layer to actually use the software layer?
It depends on, I think, what the goal is of the compat layer. Like Bart was mentioning yesterday, they have a pretty fat compat layer because they have systems where the OS is very minimal. So they're basically shifting that burden to their compat layer. Is that something we want to do, or do we say that's your problem if you want to have a minimal OS? That's not our job to fix it. I'm not sure. I don't think we have an answer.
One thing I was wondering is if it could be wise to have two prefixes. One to build the software in the software layer, and another prefix that is a stripped down prefix just for the end user. And that's the one included in the current VMFS repo.
Yeah.
Because if at the end of the lane is just if at the end of the day it's just a matter of just see, I don't know what else.
It should be mostly libraries, because that's how you hide yourself from the OS.
Yeah, and the danger is also already, for instance, with Archspec, that will pull in lots of Python dependencies, which you cannot remove anymore. So that's something that you already always would
you
get
go
in
open the pull request during your talk. That can actually help us there. We had some discussion on that this week, and maybe since we sort of reached the conclusion that Archspec is not enough for what we want to do, maybe we need to turn the wheel there and take a different direction and get rid of it entirely and just take matters into our own hands now that we understand things a bit better. And that's, I mean, at least for that aspect, that could help as well.
Yeah. But yeah, maybe that approach, I don't know who was talking, but that would not even be such a bad idea. We could maybe have two versions of the compat layer where maybe a sysadmin could choose in the CVMFS settings with these variable symlinks that we already use in the repo, which version of the compatibility layer you want to use, either the minimal one or the fat one, where the fat one is just completely filled with, well, whatever you can put in there, from LaTeX to text editors, etc. And the minimal one is just a very minimal set of packages that you need in order to provide a software layer. It will be more work to maintain, of course, but yeah, in principle, I think.
Yeah, especially that last remark is something I feel a little bit worried for here in the discussion. I mean, if at some point a couple of sysadmins or whomever wants to join the project and sort of like focus on maintaining that, I would say that's a really good idea. If not, I think we should focus on bringing this project forward and focus on sort of like being able to deploy the actual scientific software in the short term.
Yeah, no, I agree. Yeah.
Because otherwise you get scope creep and we'll be adding features in sort of like the breadth instead of making sure that we move forward in depth.
No, that's definitely true. Also, for instance, now with adding RISC-V, the more packages we need, the more issues we're likely to run into. So yeah, I agree that we maybe should first keep it minimal. Also, because our approach is different than what Bart mentioned anyway. I mean, they know what kind of clusters they're going to run on, while we open this basically to everyone. So yeah, systems with a minimal set of packages, that is maybe not really our problem.
Yeah, the focus should be on indeed making sure that the software you have in the software layer is independent from the OS and just provide stuff that's needed there. And anything else is really maybe not our problem. And they do have other ways to fix that as well. You don't have to rely on us for that.
Yeah.
For me, maybe the interesting question comes with the graphical stuff later on. I mean, once we get to the point where we start talking about graphics, what do we do there? That's a complex one.
And that was a big plus for when Jaco was playing with one of the very first versions of the pilot repo in Windows, in WSL. He was very surprised to see it doing graphical stuff. So that's a very good aspect that it's actually. Now we could push that to the software layer level as well.
Yeah, there's doing it, and then there's doing hardware support in the graphical layer, right? So like the GPU support and things like that. It's possible, right? It is possible to do. How do we do it? I don't know. I mean, it's software. I mean, CPU support for the graphic stuff. That's possible, right? We can already do that. But actually getting the GPU support in there, it's possible to do. But
So that's a set of packages where you can say performance doesn't matter. Well, in the end, yes, probably.
It definitely does. I mean, because at the end of the day, you want things like FFmpeg to encode as quickly as possible. If you're doing something like Expra, right? So if you're doing something that's doing encoding, and it needs to be fast, right?
FFmpeg is a weird beast because I think that's smart enough to basically build itself fat anyway. So whether we have it in compat layer or software layer, we're probably not gaining much by installing it in the software layer.
The Gentoo, it's gonna be optimized for the host machine. Gentoo set the flags for FFmpeg. Just
yeah, but and that's a problem, right? Because we want FFmpeg to be compatible with any.
So yeah, we need.
Yeah.
If we want that in the compatibility layer, it should be a fat build, but Gentoo is not gonna do that by default.
Yeah.
So do we know why we at some point set the path differently?
I was just looking that up. You opened the issue, Caspar.
I did? Nice.
Where is the tab?
Much better than my own memory.
In something that we change. Clearly motivated in the pull request. So we try to keep track of why we did something. Because indeed the question pops up again, like, why are we actually doing that? He sits there, right? It's well motivated, we explain why. And I think it's probably there, so say, let's find again later. That's
It just says that it was because of the system Python, right?
Otherwise, it's going to use the Python from the host. I think that's.
I was going to chip in and say, actually, the FFmpeg thing is quite an interesting test to the previous slide's philosophy. Is it processor dependent? Yes. Is it performance dependent? Yes. Should it be in the software layer? Yes and yes probably means yes. So yeah, it's kind of an interesting case of actually we probably should put it in the software layer rather than the compat layer. Yeah, interesting case, that one.
I think the criteria that Compute Canada is using currently are not, I mean, that list should be longer. Like security should be in there. Maybe you said, should it be always available or only on demand? Maybe another criterion that we should take into account. Init script uses. Our init script uses. Yeah, so it's not, the user doesn't care, but our scripts care. But there's other options there, like Hugo worked on already. So yeah. And there's other reasons that we should go beyond pure RCPEC anyway. So if we have to do that anyway, we might as well take matters into our own hands. I mean, RCPEC was fleshed out of spec, basically asked them to. I was talking to Todd and Massimiliano. I said, this bit of spec, this could be useful for other projects. I didn't mention what it was, but it was for easy. And they ended up fleshing it out. And I mean, they're working on it. They're doing releases every now and then, not very frequently. There's now, I think it's now a couple of months since the last release, and there's stuff that's been merged already that we actually want. Like I think better support for detecting Milan and Graviton 3 maybe even is not in an RCPEC release yet. Spec doesn't care because whenever something is committed in the main branch of RCPEC, they just vendor it to spec. So they just copy it over and it's in spec, they're happy. But we actually want releases to do that. We don't want to vendor this stuff. So the whole release process is a bit slow, maybe not fast enough for us. Maybe we don't have enough control. And yeah, the reasons are piling up that maybe it's not our best option anymore. Mm-hmm. And what it does is it doesn't do a lot.
I was going to say sort of like the actual implementation and an alternative was built in an hour and it's like 50 lines of bash. Yeah, it is. And and too
it's a
complex
database
for
with
what
way
we
more
need.
stuff than we actually need.
Yeah.
The database has compiler options for those specific targets, and which we don't use anyway. So there's lots of information there that is useless to us, essentially. We only care about the detection mechanism, and the detection it does is not actually what we actually want. It does instruction level detection, why we actually want to know what kind of CPU. Is it Milan, Milan X? Archspec is never going to tell us that. So we need something a bit more involved. And maybe we need to build our own thing.